Yes, shall we start? No. Who said no? Okay. In the previous class, we have cleared with the reliable data transmission, right? We got the 5 versions there, how the data has been transmitted from sender to receiver. So we have learned what is the principle of reliable data transfer from the sender to receiver, and we have the RDT 1.0 where the loop condition is occurring from sending to receiver side. No acknowledgement is adopted here. So when we overcome this, we are having the RDT 2.0 where we can remove the error condition. That is, if you unable to pass the data, the error may occur, right? So at that time in the RDT 2.0, we are applying the acknowledgements, right? We are having a negative and acknowledgements has been adopted in the RDT 2.0. So update this version to get back the drawbacks, to overcome the drawbacks of the RDT 2.0. So we have adopted with the RDT 2.1. So where we are giving the sequence number. Stop discussing. My voice is not good to shout. Okay. Don't make me to happen it. Okay. So RDT 2.1, we are having the sequence number to know which data has been failed to transmit between the sender and receiver. To overcome the RDT 2.0, we have the 2.1 version to give the sequence number for each packets of data. So that is cleared. And moving for the next topic, RDT 2.2, we are having the acknowledgement. Once the receiver is sending the acknowledgement to the sender that I have got the data 100% the well-versed data has been got. When the acknowledgement is sending, at that time particular in that situation the error may occur. At that time, to overcome that thing, this RDT 3.0 has been adopted to know that which data has been corrupted. So the acknowledgement during the sending of the data, giving the acknowledgement thing. So at that time, if the corruption occurs, to make sure which data has been corrupted. So to to overcome the confusions, this RDT 3.0 has adopted with the sequence number, and here we are having the acknowledgement is acknowledged. Okay, to give back to get rid of the diversions from the sender and receiver, between the sender and receiver. After that, we are having the in the 3.0, we are adopting the timer also to do not waste our time. So we have adopted a timer to send the packets between the sender and receiver. This is clear. Till here we have completed the portions, right? So next is pipeline protocols. The pipeline, what it explained is it's the same thing. What the data has been transmitted from sender and receiver. Here the pipeline is giving a much it is providing a good utilization. What the purpose? Is it? So pipeline, what it is giving, it is going to be the full utilization with a good bandwidth. So here the pipeline, we are transferring multiple data sets. So how the utilization is done by transferring the multiple data sets. We only saw the data, packets data has been sent in one sequence. Once the first packet is done with the acknowledgement, then we are sending the second packet. But the pipeline, what it is going to give, it allows multiple data to be transferred in a single transmission type. So the range of the sequence numbers will be increased, and also buffering at the sender and the receiver will be encapsulated. Here you can see that a stop and wait protocol operation in the first diagram. So stop and wait where we have seen in the RDT 2.0, right? Once the acknowledgement is got from the receiver, then only the sender is going to send the second packet. Stop and wait condition is going to be happen. But in the pipeline protocol, we are sending multiple packets over in one transmission time. So there is a lot of time utilization is happening, and also a good transmission is going to be happen. So here we are having a two conditions. Before going to that, the sequence here you can see the sender and receiver. Yesterday we have discussed about this formula, utilization of the sender by L divided by R divided by RTT round trip time plus L divided by R. So what is your L? The length of the packet, right? The timing you are going to send. So here you can see the first packet, it has been transmitted from the timing, initializing it to a 0. So last bit transmitted, it will be given by time is equals to len L by R. Here you can see the 3 packets have been passed in a one particular moment. Okay, in the one particular moment, the 3 packets have been transmitted from the sender. So the first packet, once it is arrives, so last packet bit arrives will be sent in, the acknowledgement will be sent once by the receiver when the last bit is going to arrive for the receiver. When the receiver is going to send the acknowledgement, once all the 3 packets is going to be sent by the sender. But the acknowledgement when we are getting from the receiver, once the first packet, whatever it is sending from the sender side, the last bit, whenever it is going to arrive for the receiver, then only the receiver is going to give the acknowledgement for the sender. Understood? The 3 packets will be arising in a one moment. So you can see the last bit packet, last packet bit arriving, it is going to send the acknowledgement. In the second packet also, whenever it is the last bit is arriving, it is going to give the acknowledgement. Same way in the third bit also. So once when the sender is sending the 3 packets, the receiver also needs to give the acknowledgement in order. So if I if I give an example like hi, hello, how are you? Okay, it should be in order. It should not be like hi, are you, how is missing. So you can't understand the message, right? Hi, how are you is the in order we are providing the message. If I'm Missly, I am give the hi, are you? Can you reply? No, you can't understand. So the same way the sender will be not understanding the packets once it is missed. So he needs to once again acknowledge the receiver. He needs to initiate the receiver, ping the receiver to send